I'm Chris, and in this lesson we're taking a look at sketching vectors. So when you have a vector, that just means that you have a line where not only the magnitude or size of the line, but also the direction that it's in matter. And with vectors, it's important to know in terms of sketching a vector, in this graph we see the initial vector v displayed here in black, and then in green, red, and blue we're going to take a look at how this vector can be manipulated if we have to adjust it with maybe a coefficient like 3, or maybe a negative sign in front, or both, a negative sign with a coefficient. So we're going to talk about how each of these will affect the length and direction of this vector. First, let's start with a positive coefficient in front. So if we were to draw what 3v would look like, 3v will be approximately the same size as the original vector multiplied times the coefficient, times 3. It just means it's going to be 3 times as large. So you start with this size vector, v. It would be the original, and I'll draw this just kind of underneath so that you can see that. But we're multiplying it times 3. This one went over 2 and up 1. If you multiply both of those components times 3, you would go a total of over 6 and up 3. And that's what's going to happen with this vector. So it'll be the same thing that we see here, except we're going to go over 2 and up 1, over 2 and up 1, over 2 and up 1 again. Basically, you're doing the same thing 3 times. So this vector that we have drawn here would be 3v. So whenever you're multiplying by a positive coefficient, if it's a whole number value like 3, that means you're just multiplying each of the components times 3, or essentially you're lengthening that vector so that the net result will be the original vector times 3. You're just stretching it out by a factor of 3. Now, other options that we have for drawing out vectors, maybe we have a negative sign in front. So let's talk about what that means. Here it's a negative 1 as our coefficient. So in terms of magnitude, since we have a 1 there, it's not going to be a different length vector, but the negative indicates that it will be a different direction. It's going to be the opposite direction of our original vector. So if v goes up and to the right with that magnitude, then negative v will be the same size, except it'll be down and to the left. So negative v will look something like this. And then lastly, sometimes you'll have a coefficient that's a negative, and in this case a fraction. So negative, we know, means it goes in the opposite direction. It's also going to go down and to the left. But in this case, we have a negative 1/2. So if you had to guess, based on what we learned from these two, when you combine them together, negative means down and to the left, and 1/2 means that you're going to take your original vector and you're going to multiply it by 1/2. The new one will be approximately, or exactly, half the size. So we're going to go down and to the left, except it's only going to be half of the size of our original vector, and that would be a negative 1/2 v for that. So hopefully you can see that the negative impacts direction, the coefficient, the numerical value in front of it, whether it's a 1 or 1/2 or a 3, tells you about the size of your new vector. For more, please feel free to watch our other videos on vectors, and thanks for watching.